Have you ever seen a picture of the night sky, but instead of just stars, it's filled with giant, glowing ribbons of green and pink light? It looks like something straight out of a fairy tale or a science fiction movie. That incredible magical light show is a real thing. It's called the Aurora Borealis, but you might know it by its more common name, the Northern Lights. These lights don't come from a city or a stadium. They are a natural wonder, a dazzling display painted across the darkness by nature itself. And they are one of the most spectacular sights our planet has to offer. What do they actually look like? Imagine someone took a giant paintbrush and dipped it in glowing, otherworldly paint. Now imagine them swishing that brush across the vast black canvas of the night sky. The aurora can look like shimmering curtains of light that seem to dance and sway in a silent breeze. Sometimes they form a perfect glowing arc that stretches from one end of the horizon to the other. They can also explode into a crown of light directly overhead, called a corona, with rays of green and purple shooting out in all directions. It's a dynamic, ever-changing spectacle that never looks the same twice. The colors are absolutely breathtaking. The most common color you'll see is a beautiful, ghostly green, like the glow from a firefly magnified 1,000,000 times. But if you're really lucky, you might see other colors mixed in. Soft pinks, deep reds along the bottom edge, hints of violet, blue shimmering within the brighter green light. These colors can shift and change right before your eyes, blending into one another in a silent cosmic ballet. It's a truly unforgettable experience, watching the sky come alive with such vibrant and unexpected hues. Seeing the northern lights for the first time is a moment that people never forget. It's a feeling of pure awe and wonder. You stand there, bundled up in warm clothes, looking up at this impossible, beautiful thing happening miles above your head. It makes you feel both incredibly small and deeply connected to the universe all at once. It's a powerful reminder that our planet and the space around it are full of incredible secrets and amazing phenomena just waiting to be discovered. It's not just a light show. It's an experience that touches your soul and sparks your curiosity about the world. So where do these amazing lights actually come from? The story of the aurora begins 93 million miles away, with our very own star, the sun. The sun is not just a calm, steady ball of light. It's a super hot, super active star made of sizzling hot gas called plasma. It's constantly bubbling and churning, and sometimes it lets out a huge burst of energy and particles. You can think of it like the sun having a giant superpowered burp. This explosion is called a solar flare or a coronal mass ejection, and it sends a massive cloud of tiny particles, called charged particles, flying out into space at incredible speeds. This stream of charged particles shooting away from the sun is known as the solar wind. Now, this isn't like the wind we feel on Earth that rustles the leaves on trees. This is a completely invisible wind made of protons and electrons, the tiny building blocks of atoms. This solar wind travels through our solar system at hundreds of miles per second, carrying with it a tremendous amount of energy from the sun. It flows past all the planets, Mercury, Venus, Mars. But when it gets to our planet Earth, something very special happens. Imagine you're at the beach, and a giant wave is coming toward you. That's kind of like the solar wind heading for Earth. This wind is powerful, and if it were to hit our planet directly without any protection, it could be very harmful to life, and could even strip away our atmosphere over millions of years. It's a constant stream of high-energy radiation that needs to be deflected. Thankfully, our planet has a built-in defense system, an invisible shield that keeps us safe from the most intense parts of this solar wind. This shield is the key to understanding why we have the northern lights. Without the sun, there would be no northern lights. The sun is the engine that drives this entire process. It's the source of the energy and the particles that eventually create the beautiful auroral display. So the next time you look up at the sun, with protective glasses of course, remember that it's not just giving us light and warmth. It's also sending out the secret ingredients for the most spectacular light show on Earth. What is this amazing invisible shield that protects us from the solar wind? It's Earth's magnetic field. You might have played with magnets before, noticing how they can pull things toward them or push them away without even touching them. That invisible area of force around a magnet is called a magnetic field. Well, our entire planet acts like a gigantic magnet. Deep inside the Earth's core, there's a spinning ball of molten iron which generates a massive magnetic field that surrounds our whole world. This field stretches far out into space, creating a protective bubble around us called the magnetosphere. This magnetic field is super important for life on Earth. It acts like a cosmic bodyguard, deflecting most of the charged particles from the solar wind. Imagine the solar wind as a river of fast-moving water and the magnetosphere as a giant rock in the middle of it. The water has to flow around the rock, and that's exactly what most of the solar wind does. It flows around our planet's magnetic shield, keeping us safe from the constant stream of solar radiation. Without this magnetic field, the solar wind would bombard our atmosphere and could damage our technology and even harm living things. But the shield isn't perfect. Some of those energetic particles from the solar wind get trapped by our magnetic field. The magnetic field lines, those invisible lines of force, come out of the South Pole, loop all the way around the planet, and go back in at the North Pole. Think of it like the pattern iron filings make around a bar magnet, but on a planetary scale. The trapped solar wind particles get funneled along these magnetic field lines, spiraling down toward the Earth's poles. This is where the magic of the aurora really begins to happen. So, our planet's magnetic field does two very important things. First, it protects us by creating the magnetosphere, which shields us from the harshest parts of the solar wind. Second, it captures some of the solar wind's particles and guides them, like a cosmic roller coaster, toward the North and South poles. This process is happening all the time, day and night. It's a constant interaction between the sun's energy and our planet's protective shield, setting the stage for the incredible light show that we call the aurora. It's a perfect example of how amazing planetary science can be. You might be wondering, if these particles are coming toward Earth, why can't we see the northern lights? Why don't we see them in Florida? Why don't we see them in California? The answer lies in the shape of our planet's magnetic field. The magnetic field lines act like highways for the charged particles from the solar wind. These highways are specifically directed toward the planet's magnetic poles. Those magnetic poles sit very close to the geographic North Pole and very close to the geographic South Pole. It's like all the cosmic traffic is being routed to two specific destinations on Earth. Think of the Earth as an apple. If you were to pour water over the top of the apple, the water would run down the sides. But the magnetic field acts like a funnel placed at the top and bottom of the apple. Instead of flowing all over, the particles are channeled directly into those funnels. The vast majority enter our atmosphere in a ring around the North Magnetic Pole and a ring around the South Magnetic Pole. When those fast-moving particles finally reach the end of their journey along the magnetic field lines, they slam into our atmosphere. Our atmosphere is made up of different gases, mostly oxygen and nitrogen. When the charged particles collide with these gas atoms and molecules, they transfer a lot of energy to them. This gets the atoms all excited. To calm back down, they release that extra energy by emitting tiny flashes of light, like microscopic silent fireworks. When billions of these collisions happen at once, the tiny flashes combine into huge moving curtains of aurora. Oxygen hits high in the atmosphere. It can make rare red light. Oxygen lower down. It makes the common brilliant green. Nitrogen collisions can create blues and purples. It's a beautiful cosmic chemistry experiment happening 60 to 200 miles above our heads. So, if the auroras happen in rings around the poles, what do we call those special regions? Scientists call them the auroral ovals or auroral zones. These are the areas on Earth that have a front row seat to the best light shows. The northern auroral oval covers the northern parts of countries like Canada, Alaska in the United States, Greenland, Iceland, Norway, Sweden, Finland, and Russia. Similarly, there's a southern auroral oval over Antarctica, which creates the southern lights or aurora australis. Because very few people live in Antarctica, the northern lights are much more famous and widely seen. The size and exact location of this auroral oval can change from night to night. When the solar wind is calm, the oval is smaller and stays closer to the pole. When the sun is very active and sends out a powerful solar storm, the auroral oval gets much bigger and expands further south. On very rare occasions, the oval can expand so much that the northern lights can be seen from the northern United States and parts of Europe. This is why people who want to see the northern lights plan trips to places located inside this special zone. Being in the auroral zone doesn't guarantee you'll see the lights. You still need clear, dark skies, but it dramatically increases your chances. It puts you in the right place at the right time, geographically speaking. If you live in a city like London or New York, you are far away from the auroral oval, so the particles from the sun simply aren't entering the atmosphere above you. The whole show is happening hundreds or even thousands of miles to your north. Think of it like a concert. If your favorite band is playing in a stadium, you have to go to the stadium to see them. You can't hear the music from your house 100 miles away. The Auroral Oval is the stadium where the Northern Lights perform. To see the show, you need a ticket, and in this case, that ticket is a plane ride to a location situated directly under that magical ring of light. People who live inside this zone are the lucky ones who get to see this cosmic performance on a regular basis, right from their own backyards. If you're ready to pack your bags and go aurora hunting, there are some incredible places around the world that are famous for their fantastic views. One of the top destinations is Norway, especially the northern part of the country near cities like Tromsø. Known as the Paris of the North, Tromsø lies directly under the Auroral Oval and offers many guided tours that take you away from the city lights for the best viewing. The stunning Norwegian coastline with deep fjords and snow-capped mountains provides a dramatic and beautiful backdrop for the dancing green lights in the sky. Another fantastic spot is Iceland. The entire country is located in a great position to see the northern lights, so you don't have to travel to a specific region. You can see them from just outside the capital city, Reykjavik, or you can venture into the wild volcanic landscapes for an even more memorable experience. Imagine seeing the aurora reflect in the still waters of a glacial lagoon, or shimmer above a powerful waterfall. Heading over to North America, Alaska and the Northern Territories of Canada are prime aurora viewing locations. Fairbanks, Alaska is particularly well known because it sits right under the auroral oval and has a high percentage of clear nights. The Yukon and Northwest Territories in Canada also offer vast, dark wilderness areas far from any light pollution, providing pristine conditions for watching the sky light up. In these remote locations, the silence of the winter landscape combined with the silent dance of the aurora creates an atmosphere of profound peace and wonder. Finally, you can also travel to Swedish Lapland and Finnish Lapland. These regions in the far north of Sweden and Finland are sparsely populated and offer incredible opportunities to see the lights. You can even stay in a glass igloo, a special hotel room with a clear glass roof, allowing you to lie in a warm bed and watch the aurora dance above you all night long. Imagine falling asleep to the gentle, silent glow of the universe swirling overhead. Each of these locations offers a unique culture and landscape, but they all share one amazing thing: a VIP pass to Earth's greatest natural light show. Now that you know where to go, you need to know when to go. The best time of year to see the northern lights is during the winter months, not because the lights are stronger in winter, but because nights are much longer and darker. The aurora happens year-round. In summer up north, the midnight sun keeps it light 24/7. You can't see stars or auroras with the sun up, so you need darkness and lots of it. Peak season runs from late September to early April. Equinox months are often especially good: September, October, March, April. During equinoxes, Earth's tilt can let more solar wind interact with our magnetic field, sometimes producing more aurora. But really, any dark winter night can work. You need clear skies. Clouds can hide an aurora that is dancing right above them. That's why you should plan several nights. Patience is key. Get away from city lights. Light pollution washes out the faint glow. Check the space weather forecast. Scientists monitor the sun and predict incoming solar wind. Aurora forecasts help you know if chances are high or low. Right location, the right time of year, a clear, dark sky, and a bit of luck from an active sun gives you the best chance of witnessing this incredible natural wonder with your own eyes. For thousands of years, long before we had the science to explain them, people have been looking up at the northern lights with a sense of wonder and awe. Many ancient cultures and indigenous communities created powerful myths and legends to explain the dancing lights in the sky. Some Norse legends said the aurora was the reflection from the shields and armor of the Valkyries. They believed the lights were a bridge that allowed brave warriors to travel to their final resting place in Valhalla. In Finland, a common folktale tells of a magical creature called the tuulikettu, or fire fox. This fire fox ran across snowy landscapes so quickly its tail swept up snowflakes and sent sparks into the sky, creating the aurora. Many indigenous groups in North America had their own beliefs. The Cree believed the lights were the spirits of their ancestors dancing in the sky, and that if you whistled at them, they would dance closer. These stories show how deeply the aurora has touched the human imagination. Even today, the aurora holds a special place in our hearts. It connects our planet to the wider universe. When you watch the northern lights, you are literally seeing the effects of the sun on our world in real time. You are witnessing a direct interaction between our star and our planet's atmosphere. It's a stunning visual reminder that we live on a dynamic planet in a very active solar system. It's not just a local weather event, it's a space weather event. This is why seeing the aurora is about so much more than just seeing pretty lights. It's about experiencing a profound sense of connection to nature, to history, and to the cosmos itself. It sparks curiosity and makes you ask big questions about our place in the universe. It reminds us that there are still incredible, wild, and magical things in the world that are far beyond our everyday experiences. It's a humbling experience that can inspire a lifelong passion for science, exploration, and the natural world. The aurora connects the past to the present and the earth to the stars. So why should you make the effort to see the northern lights if you ever get the chance? Because it is one of those rare experiences that truly lives up to the hype. No picture or video can fully capture the feeling of standing under a vast, dark sky as it comes alive with silent, shimmering light. It's a three-dimensional experience. The lights feel miles away and close enough to touch. They move with a grace and beauty that seems intelligent, like a living entity dancing just for you. It's a moment of pure, unadulterated magic in a world that can sometimes feel all too ordinary. Seeing the aurora is also an adventure. It often requires traveling to remote, beautiful, and wild places. It means bundling up against the cold, stepping out into the crisp night air, and having the patience to wait and watch. The anticipation itself is part of the experience. The thrill you feel when you spot that first faint green glow on the horizon is unforgettable. The adventure of the hunt makes the reward even sweeter, creating memories that will last a lifetime. Most importantly, seeing the northern lights inspires a deep sense of wonder. In our busy daily lives, it's easy to forget to look up. We're often focused on our screens, our jobs, and our schedules. The aurora forces you to stop, to look up at the night sky, and to contemplate something much bigger than yourself. It encourages curiosity and reminds us that the universe is filled with incredible phenomena that we are only just beginning to understand. It can ignite a passion for astronomy, for physics, and for protecting the beautiful planet that makes such wonders possible. If you ever have the opportunity to stand beneath the dancing glow of the aurora borealis, take it. Go see the sun's energy paint the night sky. Go witness the magic of our planet's magnetic field in action. It's more than just a bucket list item, it's a chance to connect with the universe in a deeply personal and unforgettable way. It's a reminder that our world is full of wonder, from the smallest atom to the largest star, and it's all out there waiting for us to explore. The northern lights are a radiant invitation to do just that.